G-Tech on Discord gave me a tip, and he wrote that the reason the bees were not detected properly in the final results was not the size of the image in the bee, but instead the scaling would change the aspect ratio of the bees, so that they were shaped in a way that the detection network does not expect. In this first image, in this screenshot, I show a preview scale. So this is a 300 by 300 scaled, and in the background we can see the full image. So that's the full resolution as 1080p. And what you can see is that there are no details missing on the preview, but for example the angle of the stick does not match because the aspect ratio was changed to have the quadratic image. So I went ahead and changed this, and what I found was that you can actually reduce the resolution of the video, and in this case both images, a preview and the real video frame, have the same resolution, and they keep the aspect ratio the same, so the bees don't look misshaped. We can also have a quick look at the code. So basically the only thing I added here is the video sensors, the video size, and then you have to select a region where this smaller size is cropped from the original image. So I set this to the middle of the image, so it's slightly to the lower right will be the final image, because this set sensor crop sets the upper left of the cropping area. So just to see the differences, I've slightly modified the code where we load the images I took during the field test. There are basically two different ways we could go about this. So we can either just choose a piece of the image and use that. For example, frame, the center of the frame, just as shown previously. But in this case, I've decided, because we already have the images and we just want to process them, that time is not a problem. So what I do here is I divide each frame into 18 smaller chunks, and each chunk is 300 by 300 pixels, so that's the input resolution of the neural network. I divide the 1920 pixels lengthwise into 6, and the 1080 pixels in the height of the image into 3. So I don't cover the whole image, but instead I leave just the outer edge on the right and lower side, and then I iterate through this through these positions, and for each of the 18 positions I take the 300 by 300 cropped image. I run this through the neural network. I return the bounding boxes of the detected bees, and I mark them on the original frame. And then I go into the next smaller piece, and I repeat the same process until I've covered the whole image. And this way we basically have a really high resolution for the neural network. But it would take 80 times as long if we did it in real time for each frame. So the frame rate would drop to about 1 frame per second. Now we can compare the original detections, which we have previously, to the new ones, where we have 18 smaller frames per frame. I hope you can see this well enough. Probably not. But what we can see now is the frames, the old one on the left and the new one on the right. For instance, here we detect 3 bees in this frame with the old method. And in the new one, we only detect 1 bee, but it's a smaller one on this white background. So this is not a good example here. In this case, the performance did not improve. On this image, on the other hand, again, we don't detect one bee which was previously detected, but this time we detect actually the 3 bees that are on the platform or next to the platform down here, which the old method did not cover. But I also have one example where you can really see the difference this method of bee detection makes. So this is the image I want to highlight. In this case, this is the old detection method of where we use the frame as a whole. And what you can see is it detects 5 bees here, and the bounding boxes for the bees are way too big, so there are multiple bees inside each bounding box. We have to admit this is a really stress test for the detection, just based on the amount of bees in the frame, and they are overlapping. There are multiple bees overlapping at the same position at multiple times in the frame. We have a difficult background here, and there are some contrasts up here which are misdetected in this case. So let's see what the new version, where we take 18 smaller pieces of this image, makes from it. This is the result of the updated process, and we can see this now detects firstly a lot more bees, and secondly the bees are individual bees. In each bounding box there's exactly 1 bee. The bounding box fits exactly to the bee itself, and we can see with the next few frames I'm going to show that this method really works well in this case, at least compared to the old one. Just look at the amount of bees that are detected here. It's not perfect, there are still a lot of bees missing, but it's way better than what we have seen before. And again, this is the same algorithm for detection, but we just have a different method of feeding it this input frame.